set?
Yeah.
It'll work. Okay, so first thing we need to do is get the machine running, or the instrument running. So on switch is here. From that on, the 3 detectors are going to turn on, and there will be a series of beeps. Once all the beeping stops and all of these say connected, then we can start the software. So we'll wait.
All right.
Very interesting so far.
Yes. All right, I can tell you it takes about 1 minute.
Okay, should be able to start it. So the software we're starting is Unicorn 5.11. I'm going to start the screen recording now. So we'll start this software. Make sure you start the software after the instrument is connected, otherwise you're going to have to exit out of the software. You'll probably have to hard close it down by going into Task Manager and ending the process. As long as this is on and connected, this screen should come up. We only have 1 user, and that's default.
Kevin, you might unplug in that shaker incubator. I think it's the white and black plug.
Okay. So the first thing we're going to go to is System Control. This is what's going to be used for all of our method in this case. All right, before we do anything with the Akta, we need to prime the pumps. So carefully open the door, don't spill anything. To prime the pumps, it's always the left-hand knob. There's 2 pumps, so if you want to show that there's a second one there. So in each case, connect the syringe to the pump, like so. Turn the knob about a half turn counterclockwise, and then just pull some liquid through, and make sure you don't have bubbles in your line. So watch your lines at the top, make sure there's no bubbles all the way through. And pull about 20 mils of liquid in total.
I guess what's important is that there's no more bubbles coming through.
Yeah. With this system, if there are a few bubbles, it's not going to kill you. On lesser FPLCs, bubbles will destroy your pumps. Okay. We'll do the same thing for B.
So what does A and B refer to?
It's the 2 different pumps. So we have 2 pumps and they both go to 1 mixer. A and B are the same throughout. So up here, so any of the A tubing goes through the A pump, any of the B tubing goes through the B pump. So there, the pumps are primed. So let's.
So you close those black knobs again.
Right. If you open them while there's no syringe, they'll just start dripping. So make sure to close before you detach the syringe. Just quickly on the inside of the machine before we close it here, this is the mixer. So this is what is actually mixing for the two pumps. So if you do a gradient, everything goes through the mixer before actually going through the system. The mixer is also connected to the sample pump, so you can mix up to 3 different
Streams.
yeah, I guess streams or buffers or whatever all at once. The sample pump has its own, or needs to be primed on its own. That priming step is a little bit different. We'll go over that later. We have the column valves. I guess this is the sample valve here, the column valves, the injection valve, the outlet valve, and this one here, this is just connecting pretty much everything and then going from the mixer and down to the pumps. So this is just kind of the middle hub there. All right. So first thing we want to do is wash the system. We have plenty of water and ethanol on here right now, so we can rinse with ethanol on here. It says A12, so that means it's on inlet A1, position 2 on A1. So if we want to wash first with ethanol, we can come into our system control by clicking any of these buttons with the double arrow and go into there. We're going to do a wash, so that's going to be in the pump. We can either wash manually by setting the flow rate ourselves and doing that, or we can use one of the pump wash settings. So we can wash each inlet we're going to use, and we can say for A1 which inlet we want to wash. So if we're using the pump wash, we want to make sure we have at least 100 mils in each of our buffers. So we're fine here, here, and here. So we'll be washing with a combination of ethanol and water for this.
Is there any reason why you pick those?
Water and ethanol. Ethanol is nice to have in the system if it's going to be sitting for a while, because you won't get any buildup of bacteria, and there's no salts in there, so you won't get any scale. Water is just nice because it has no pH really, and it's good to flush out everything, especially when we're working with protein A. So
you're gonna wash all of the inlet positions?
Yes. So you can choose which ones to wash. In this case, let's just go ahead and wash all of them.
So you do that every time you start up the machine?
Yeah, if you're running it continuously, say you're doing 3 runs in a week, you don't need to worry about washing the pumps each time. Just put some ethanol through the instrument and let it sit, and then just kind of flush out what's there.
But if it's been a while, then you definitely want to do that.
Mm-hmm. And the Pump Wash Explorer is nice. It will wash every single valve and outlet from that valve for you.
Okay, so right now the waste is going into the waste bottle there?
Yes. You can see it kind of spurting out through there. So right now you can see it's cleaning out the injection valve because you can see a little bit of liquid moving through there.
So this is what position?
You can see the positions on the side. I think that one is, let's see, 765 likely. Probably also labeled.
Oh, it's way there. Yeah, number 5. I can see it now. So that injection valve V1, is that A1?
No, the inlet valves are actually on the back of the instrument, so we can't really see those. A1 is, yeah, just on the back. A1 corresponds to all the buffers on the top. So, yeah, that's a little different.
And how long do you do this?
It'll stop once it's done washing.
Okay, so we don't have to set any time or
Right.
volume.
While this is washing, I'm just going to set up a fake sample. Actually, we can just use this water here. That's fine. Just waiting now.
All right, so it's done, so it stops buzzing and whirring.
Right. So that means your system is washed and ready to go. So now what we want to do is put our buffers on that we would use for an actual run. We're not going to do a full run, so I'm not going to put actual buffers on. But just to show how to switch buffers, I'm going to take filtered H2O and replace one of the buffers up here with filtered H2O. So the current one that's on B1, so that's this, I'm just going to put it into filtered H2O. So you want to make sure you have some Kim wipes handy and whatever buffer you're going to be using. All buffers need to be filtered with at least 0.4 micron filters before being put over the Akta system. So we have this. We want to make sure we're not transferring buffer. In this case, I'm going water to water, so it doesn't matter, but just for sake of demonstration, we'll clean off the buffer with a Kim's wipe.
So that thing is just a weight?
Yeah, it's a weight and it's got a mesh
You just
filter.
keep out the big debris?
Yeah. But you still need to filter anything that's going to have this on it. Okay, so as we're putting this in, we're going to get air bubbles stuck on that mesh at the bottom there. So we want to kind of make sure we're swirling it around so that air bubbles aren't getting trapped and we're not going to pull up any air. So once that's on, we want to make sure that whatever our flow path is going to be, our buffer of interest is filling up that flow path. So we're not putting some ethanol over our column or something that we were using to wash the system that's going to hurt our column. So we're going to look at our inlet, in this case it's B1, and we're going to come over to here. And for our instructions, we're going to go to flow path. So whenever we're changing anything about the flow path, whether it be the inlet systems or any of the valves, we're going to be doing that on flow path here. So we're going to be looking at pump B inlet. This is on B1, so we're just going to make sure that this position is also set to B1, and we can insert that to our instruction list. Then we need to tell the pumps to send only buffers from B. So we can go to pump, set gradient. We want 100% of the buffer to come from B. We're not going to set a length because we're not actually doing a gradient. We're just telling the instrument we only want buffer B. So we're going to insert that. Next, we need to give it some flow to actually push the buffer through the instrument. So we'll go to flow. We don't have any column attached right now, so we don't need to worry about overpressuring a column, but you still don't want to throw too much liquid through the machine and create some undue pressures on the valves, which could hurt some of the connectors. So
go easy on the flow, even if there's
right.
nothing on.
So we'll give it a maximum of 20 mils per minute. That means we're going to need to run this about 1 minute to get our buffer all the way through the instrument. Next, we need to make sure that we're putting our waste where we want it. In this case, this is not buffer that we're going to need to save, so we're just going to put it through our waste valve in the fraction collector. So we look at the fraction collector and it says it's outlet valve 2. So again, if we're changing flow path, we go back to flow path, and we're going to choose our outlet valve, and we're going to make sure this is set to F2.
What happens if it's F1?
If it's F1, you can find the outlet for 1 from the outlet valve and follow this line, and that line is going to end up in your waste container. So
that would work too.
It would work fine, right? But in this case, just for demonstration, I want to put it through and have it just, yeah,
And the
go into the
waste
sink.
for the fraction collector just goes into the sink, right?
Right. There's this line that comes out of the fraction collector here. It goes back down behind the instrument into a sink that's sitting behind the Akta.
All right, so it just goes up into this sink here.
Yes. Okay. So we're gonna go ahead and set. Just for demonstration purposes, we're not worried about pressures right now, like I said, but for demonstration, we can go to alarms and monitoring and set a pressure alarm. So we're going to set our pressure alarm at 0.5 megapascals. That's usually the limit for columns. Low alarm we don't need to worry about. We're going to insert that. These are pressure alarms for the A and B pumps. If you're using a sample pump, which we'll get to later, you need to set its own pressure alarm. So there's two different detectors for pressure. You can also set alarms on this for air, UV, pH, anything like that. So if you are worried about any of those, you can set that. So in this case, we're going to go ahead and run it. So once we've got everything set, we can execute our
So you've got all the
list.
instructions listed here now,
Right.
and then it's just going to do all of them sequentially once you hit execute.
Right. And it will also execute the current parameter that you're on. So make sure you're not on some random parameter when you hit execute. So in this case, we already have a pressure alarm there, but it's going to set another pressure alarm. So they're not going to compete. The last one's just going to overwrite the first one. So I hit execute. We can see the flow has started. We're on inlet B1, and we can see liquid going here.
What's that alarm?
Pump. Okay, so we actually got an overpressure alarm. We are at 0.51 megapascals, so we're
So that flow
going
rate
too
that
much.
you picked was a little bit
Little high.
too
So
ambitious.
we'll go back to flow or to pump. Take our flow, pull that down. We'll go 10 mils per minute in that case. We can insert that or execute it either way because that's the only thing we're changing. We'll have to acknowledge our alarm. Otherwise, it's just going to wait 30 seconds and then try again. So we'll acknowledge. And then we have to hit continue. So anytime the machine is paused, you have to continue before it's actually going to continue. And we can watch our pressure here. And we're not getting anywhere near that 0.5 again. And so right now we're running for an indefinite amount of time. If we want to run a specific amount of a buffer over the instrument, we can set that. So we can come to here, go to other, set a pause timer. We can go with time or accumulated volume. We're going to go with volume. We're going to run 20 mils. This will take 2 minutes. We can insert this or execute it either way. It doesn't matter, so we'll just execute.
So execute is fine if you just want to do a single command.
Yes.
All right, so we're going to wait 2 minutes.
Yes.